Okay, these are the notes for Unit 2A for Math 4. Now today in 2A, we're going to be talking about piecewise functions. One of the things we're going to do is be able to look at a graph and be able to make a function from it. We're also going to be able to look at the function and make a graph from it, both forwards and backwards. But also one of the things that we're going to wind up doing is taking information that is basically a word problem and turning it into a piecewise function. So those are the things that we're going to do today. Now, let's start with if I'm given the function, how do I make the graph? For me, one of the easier ways to do this is to start with, take it one piece at a time, this guy right here. And sometimes I will do a t-chart. Now they're saying when x is less than -2. I'm going to include -2 because I need to have a place for an open circle. So I'm going to remind myself that this guy is an open circle. Well, when x is -2, y is 3. When x is -3, y is still 3. And so we sort of get the idea there. We're going to go to where y is 3. That's where y is 3. And we're going to start from -2, and we're going to put an open circle on -2. And then the -2, 3, -3, 3, -4, 3. We sort of get the idea that it goes on forever that way. So, 1 down, 2 to go. Now we'll pick up this next guy. And we can do a t-chart, which is going to start at -2. Now this one's not open. And it goes all the way down to +4. Now, when I stick a -2 in that equation, I get -4 minus 4 is -8. -2, -8 is going to be my starting point. And by the time I get to 4, that's 8 minus 4, that's 0.4 and 4. So I know that I'm going to start at -2 and -8. That's -7 and -8 would be down here. And we're going to go up as far as 4, 4. 1, 2, 3, 4. We're going to go for those two. And, you know, this is a linear equation, which means I have a slope of 2. So I know I'm going to go up 2 over 1, 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 and up 2 over 1. So I'm going to connect those two endpoints. And that is my middle piece. That is the graph of the middle piece. Now, you can do the whole t-chart if you want to, but I'm mostly concerned with the start and the endpoints. Now, with this last one, there's not really a way to get around the idea that I probably need to do a t-chart. But I'm going to start at 4, and again, 4 is an open circle. And when I stick a 4 in there, 12 minus 4 squared, that's 12 minus 16. That's going to leave me with a -4. And then when I put in 5, 12 minus 5 squared, that's 12 minus 25. That's going to leave me with a -13. Well, you can guess that this is only going to get worse. So let's go to 4, -4. There's +4, 1, 2, 3, 4, 1, 2, 3, 4, -4. And by the time we get to where x is 5, we're all the way down to -13. So it's going to do, you know, sort of a curve like that. It is a parabola. It is a quadratic. And so now we've got a sense of where this graph is. Now let's answer some questions from it. If I want to know what f of negative 4 is, I'm basically asking what happens when x is negative 4. Well, that would be this guy. And anything in that whole, from negative 2 down, the answer is always 3. Now, what about f of 1? Well, 1 is going to fall between negative 2 and 4. So we're going to put 1 there. 2 times 1 minus 4 is 2 minus 4. That's negative 2. Now, when we jump to this guy, f of 4, we're going to have to watch both him and him and make sure that we grab the right one. Now, you want the one with the equal sign, because that's where it actually is 4. This is just an open circle down here. 4 doesn't count. But 4 does count up here. So we're going to say, what is 2 times 4 minus 4? That's 8 minus 4. That's 4. And then lastly, we're going to say f of 6. That is definitely above 4. So we're going to say 12 minus 6 squared, which is 12 minus 36, which is negative 24. Okay, that's number 1. Now, number 2 is basically taking the same thing and asking the question, is it continuous or not continuous? Now, I'm going to show you the algebraic way, and then I'm going to go back and show you how to tell on a graph whether it's continuous or not continuous. But I don't know that this was necessarily showed in Math 3, so we're going to cover that. The thing that you've got to watch is the place where these guys trade off from one piece to the other piece. It is that negative 2 that's going to tell us whether or not this thing is going to be continuous or not. And the answer is that when I plug negative 2 into each one of these functions, each one of these pieces, I better get the same answer. If it's going to be continuous, it's going to have to give me the same answer. Well, here, if x is negative 2, and y is going to be 3. But now down here, if x is negative 2, I'm coming out here and saying 2 times negative 2 minus 4 is going to give me negative 8, which means negative 2, negative 8. These guys do not match. So it is non-continuous. Anytime you have a stinker in the bunch that does not match, then you do not have a continuous function. Now, you're also, even if the negative 2's had worked, we would have to check the 4's and make sure that the 4 here matches the 4 there. If it's going to be continuous, it has to work on every time you do that. Now, let's go back up and look at the graph of this thing. This is the same equation. This is the same graph. What they're basically telling you is that if you have, we used to look at it to say, oh, look, there's an open circle and there's a closed circle that covers it. And there's an open circle and there's a closed circle that covers it. So that means that my x's are all covered. There are no gaps in x from negative infinity to positive infinity. That is not how we define continuous. How we define continuous is, did that closed circle live inside the open circle? Did they take up the same point? If that happens, now it's continuous. But if it's open up here and closed down there, that's not continuous. There's technically a break in the action. Even though the x's are all covered, you have issues. So that is their definition of continuous versus not continuous. Now, this guy was fun. We're going to look at creating our own function, f of x equals, and we're going to have 3 pieces to it. We're going to have blue and red and green. Now let's start with the blue. All right. That is a line that goes from negative 1 down. As far as x's are concerned, it is everything -1 and down. As a matter of fact, we could say x is less than -1. Now, because there's a solid blue dot there, we're going to say less than or equal to. All right. Now, what do we write for an equation for that line? Well, if it had kept going, it would have crossed the y-axis up here at 2. And I can look at the line and say it's going up 1 over 1, up 1 over 1, up 1 over 1. That's a slope of 1. 1x plus 2. And that is the equation for this guy. So we've covered our blue now. Now the guy in red, I'm looking at this graph and I see a blue dot and I see a green dot, and where are the red dots? Is this, are there red closed circles, or are they open circles, or what? Well, I would put it to you this way: blue is clearly a closed circle. Green is clearly a closed circle, which I have to believe that, and you can't have, red and blue have the same point. So that means that red is going to have some open circles there. So we're going to say that red goes from -1 up to +1, and it's not going to have any equal signs because it's an open circle on both ends. So we could literally be doing this, and it would make sense. Now, so what is my function of the right? This is a constant function. We dealt with that earlier. Whenever it's a horizontal line with that, y is always 1. Y is always 1. Now we're going to play with the green, and the curve of it looks like it ought to be a parabola. I will go ahead and tell you that for this particular course, this particular unit, we're not going to go past parabolas. We'll do constant functions, we'll do linear functions, we'll do quadratic functions, but we're not going to get any uglier than that. Now, if I were to, I'm remembering that old rule that says, if I'm starting at the center, with my vertex, and I go over 1, up 1, oh, that works. I go over 2, up 4, oh, that works. This is telling me that my vertex is probably at the origin. And if I have a parabola with a vertex at the origin, it does not appear to be stretched or flipped or anything like that. So this is just y equals x squared. Y equals x squared. And of course, it is anything 1 and up. So it has to be greater than or equal to 1. So that is what our piecewise is going to look like when we get done with it. And I'm going to leave the red circles there just to accentuate what we are already presuming about this. All right. Now, the last one was a bit of a challenge because we had to figure out, we had to take the word problem and come up with our own piecewise equation. So we're going to start with the function is so we've got 3 pieces to the equation. I'm going to start with this guy. And we're going to do it like this, where this is the charges, and this is the pounds, how much weight. All right, so if the groomer charges $35, it's a flat $35 for the dog. The dog has to be 15 pounds and under. 15 pounds is included, so I'm going to do less than or equal to 15. Now, hang on a second here. I've got a graph here that goes into negative numbers. Is it possible to have a dog with a negative weight? Can I have a dog that weighs 0? No. If you have a dog, it weighs something. So it has to be somewhere above 0. you can't say, less than or equal to, because it can't be. You can't have a dog that weighs 0 pounds. That's just not going to happen. All right, so we'll come back to the graphing part when we finish with everybody else. All right, the next level is between 15 and 40 pounds. She charges $40. Flat $40 fee for somewhere between 15 and 40. Now, this is where the challenge comes, because when we're talking about something that is greater than 40, the dog is over 40 pounds, she charges $40 plus $2 for each pound. Now, we ran into a problem when we did this, because let's say the dog is 50 pounds. Well, that's $40 for the first 40 pounds, and then $2 for each pound after that. That ought to be, 10 pounds times 2 is 20, plus the 40 is 60. That ought to be 60. If I write it like this, and my dog weighs 50 pounds, 2 times 50 is 100, plus 40 is 140. We missed something somewhere, and the idea is that the $2 per pound is only when it's above 40. So what we're going to do is we're going to do this and do it like that. Now, I'm going to rewrite that down here, because to be honest with you, as a piecewise, we probably ought to simplify that and clean it up a bit and write it in a simplified form. So 2 times x is going to give me 2x. 2 times negative 40 is negative 80. And negative 80 plus 40 is still minus 40. So my 50-pound dog would be 2 times 50 is 100. Minus 40 is 60. Now, that makes sense. Now, we have one other small problem. I'll let you pause for a moment and see if you can figure out where we missed something in this problem. Okay, I will tell you where we missed something, and that is what happens if somebody walks in with a dog that's exactly 40 pounds. Look at the directions. The red says between 15 and 40, and the blue says over 40. Well, what happens if the dog is exactly 40? Well, kind of, if she's going to charge, if the groomer's going to charge $40 plus 2 for each pound after that, then you're going to have to presume that the 40-pound dog is going to cost $40. What we need to do is we need to adjust this guy and put an equal sign beside that 40. So x is less than or equal to 40. That's how we'll otherwise you're going to have a groomer that's going to wind up with customers saying, my dog weighs exactly 40, I should get it for free. Yeah, that's going to happen in the real world. All right, so let's start graphing this puppy. Now, we said that in my hint in the directions was to let each line count for 10. So if I'm going to start with a $35 charge, 10, 20, 30, 35, it's going to be an open circle there. Because again, I can't have a dog at 0 pounds. But anything above that, and we're going to go all the way up to 15. That is what that part is going to look like. That's the green part. Now the red part is going to move from $35 up to $40, and it is going to do this. I didn't really get it close. Let's try it again. All right, that's about as close as I'm going to get. That's on the line, on the $40 line. And it's going to go from 15 all the way up to 40, 10, 20, 30, 40, with a solid dot there. Now this point, we can already make the judgment call. Is this continuous or non-continuous? And the fact that the closed circle and the open circle are not sitting on top of each other, this is not continuous. All right, now we need to do this guy. This is 2x minus 40. Minus 40 is your y-intercept, 20, 30, 40. So we would start down here, and my 2x slope tells me up 2 over 1. Up 2 over 1, up 2 over 1. And we're going to pick up there with an open circle. And we're still going to keep going up 2 over 1, up 2 over 1. And our line is going to go in that direction. And we no longer need these guys down here. So that is what our graph should look like. Now, at this point, they ask you, so what about a 60-pound dog? Egbert's dog, tiny, weighs 60 pounds. So the question becomes, if I have a 60-pound dog, is that going to be up here with the green or the red or the blue? 60 sounds like it is more than 40. So this is going to be with the blue. We're going to use the 2x minus 40 equation to figure out what's going on here. And if x turns out to be 60 pounds for the dog, that is 120 minus 40, which is 80 pounds, or excuse me, $80. And this is going to figure out how much the dog is 60 pounds, it's going to cost $80. Now, this is, it's a fairly short set of notes, but also largely because there's a lot of review in this. We'll get into heavier notes as we move into Unit 2.